Difference between NumPy and Python 3.5 plus matrix multiplication at. I recently moved to Python 3.5 and noticed the new matrix multiplication operator, at, sometimes behaves differently from the NumPy operator. An example for 3D arrays. The at operator returns an array of shape, while the NumPy function returns. How can I reproduce the same result with NumPy? Are there any other significant differences?
The at operator calls the arrays __matml___ method, not dot. This method is also present in the API as the function np.matml. From the documentation, matml differs from dot in two important ways. Multiplication by scalars is not allowed. Stacks of matrices are broadcast together as if the matrices were elements. The last point makes it clear that dot and matml methods behave differently when past 3D or higher dimensional arrays. Quoting from the documentation some more. For matml, if either argument is n greater than 2, it is treated as a stack of matrices residing in the last two indexes and broadcast accordingly. For np. For 2D arrays it is equivalent to matrix multiplication, and for 1D arrays to inner product of vectors, without complex conjugation. For n dimensions it is a sum product over the last axis of A and the second to last of B.
The answer by at AJCR explains how the dot and matml, invoked by the at symbol, differ. By looking at a simple example, one clearly sees how the two behave differently when operating on stacks of matrices or tensors. To clarify the differences, take a 4x4 array and return the dot product and matml product with a 3x4x2 stack of matrices or tensor. The products of each operation appear below. Notice how the dot product is a sum product over the last axis of A and the second to last of B, and how the matrix product is formed by broadcasting the matrix together.
In mathematics, I think the dot in NumPy makes more sense, since it gives the dot product when A and B are vectors, or the matrix multiplication when A and B are matrices. As for matml operation in NumPy, it consists of parts of dot result, and it can be defined as. So you can see that matml A, B returns an array with a small shape, which has smaller memory consumption and make more sense in applications. In particular, combining with broadcasting, you can get, for example, use the following piece of code to convince yourself.
Just FYI, add and its NumPy equivalents dot and matml are all equally fast. Plot created with perfplot, a project of mine. Code to reproduce the plot.